Yes, friends. So today I'm taking questions based on polygons. Okay. Now, in case of polygons, what are the regular polygons? Let me talk about. Now, regular polygons means when each angle and each side, or every side of a polygon, or any many multi-sided figure, if those each angle and each side is equal, that means every angle of a polygon is equal and each side is equal. That known as regular polygon. For example, in case of a regular polygon, let me take example for three-sided figure, okay, triangles. So when it is a regular triangle or regular polygon, example is equilateral triangle, regular polygon of three-sided, or when sides are three. That means a triangle which is having equal sides and equal angles. That means equilateral triangle. Okay, so equilateral triangle is the exact example or correct example of regular polygon. When in case of quadrilateral, when n is equal to 4, sides are 4. Okay, when a four-sided figure is there or polygon is there, in that case, regular polygon is the best example of this regular polygon. In case of quadrilaterals, is a square, because in a square, each side is equal, each angle is 90 degree. I mean, every angle is 90 degree, or each angle is equal. So equal sides and equal angles. That figure is known as regular polygon. Okay, regular quadrilateral, regular triangle, regular pentagon, regular hexagon, etc., or regular heptagon, regular octagon, or regular nonagon, regular decagon, etc. Okay, or n-sided figure. So n-gon means n-sided figure or n polygon, n-sided figure polygon. So this is known as regular polygon means. So regular polygon means when sides are equal, angles are equal of a polygon, that polygon is known as regular polygon. Okay. In case of triangles, equilateral triangle is a example of regular polygon of three-sided figure, or square is example of four-sided figures, okay, or quadrilaterals. That is how we can define them. Now let us take these questions one by one. So these questions are based on polygons that I am taking here. Okay, so now let me take these questions one by one. First question, what is first question say? Question number 1 says that the sum of the interior angles of a polygon is 60 degree. So what is given to us? 160 and 20 degree. What is given to us? We are given sum of all the angles, sum of the interior angles of a polygon is equal to 1620 degree. To find, so here we have to find, find how many sides are there, the sides or number of sides. To find number of sides of the polygon, number of sides of the polygon we have to find out. Solution. Now see here the solution. Now we know that each angle of a polygon, since each angle of a regular polygon or of a regular polygon is equal to 180 degree into n minus 2 upon n. This is the formula for finding each angle of a regular polygon. But we are given here sum. What is sum of all the angles multiplied by n, and n cancelled out. Therefore, sum of interior angles of a polygon is equal to 180 degree into n minus 2. Why? Because multiply by n number of sides, so divide by n and multiply by n, and cancel out 180 degree minus this one. But here it is given, but sum of interior angles of a polygon 1620 degree. This is suppose first equation, this is second equation. This is given. We are given here the sum of the interior angles of a polygon is 1620 degree. So from first and second, equating them. From first and second, we have 180 degree into n minus 2 is equal to 1620 degree. Okay, or n minus 2 is equal to 1620 degree divided by 180 degree. 0, 0 cancel out. Okay, and then let me divide it by 9. So 9 2 is 18 and 9 1 is 9. Remaining 16 minus 9 is 7, 72. 9 8 is 72. So 18 upon 2, that means 9. Or this implies that n minus 2 is equal to 9, or n is equal to 9 plus 2 is equal to 11. Therefore n is equal to 11. Means sides of this polygon are 11. 11 sided figure is this. So let me write it here. Therefore sides of the given polygon is equal to 11, or n is equal to 11. This is the answer here. This is 11 sided figure. Alright, let me take now next question. Now question number 2. Let me talk about question number 2. So question number 2 here. Question number 2 says one angle of a pentagon is 60 degree. If all the other angles being equal, find each of the other angles. That is the point. So here we are given what is given to us. One angle of a pentagon. Pentagon means 5-sided figure. Pentagon is equal to 60 degree. Okay. To find here, so we have to find here value of each angle. Value of each angle. To find each of the other angles. Find each of the other angles. Each of the other angles of the pentagon. Because one angle is this given. Now we know that sum of the angles of a pentagon is equal to how much? Let me find out that solution. So here solution. Since sum of angles of a pentagon is equal to 180 degree into n minus 2, n means 5 minus 2, equal to 180 degree into 3, that means 540 degree. 540 degree, 18 3 are 54, so this is 540 degree. So sum of 5 angles of a regular pentagon is 540, but one angle is this. Therefore, the sum of 4 equal angles or remaining 4 angles. The sum of 4 equal angles is equal to 540 degree minus 60 degree. But this one angle of pentagon 60 degree is given. So out of the total sum of 5 angles, we have to subtract 60 degree. We get here how much? Yeah, this is 480 degree. 480 degree. Therefore, each of the 4 equal angles is equal to 480 degree divided by 4. That means 120 degree. So remaining angles, each angle will be of 120 degree. 120 degree plus 480, 480 plus 60, that means 540 degree. This is the answer here. The answer is 120 degree. Each of the 4 equal angles is equal to 480 upon 4, because remaining sum of the 4 angles was 480 degree. Each angle, remaining 4 angles will be 120 degree. This is the answer here. Question number 2. Okay, this is question number 2. We have completed. Let us take now question number 3. Question number 3. Let me now talk about. Before that, let me clean this. Okay, now question number 3. So we are talking about polygons. Questions based on regular polygons or polygons here, many-sided figures. Okay. So let me take now next question, number 3. So question number 3 now. Question number 3 says the number of diagonals of a regular regular heptagon is how much? First of all, to find here or given here, so we have, let me write, given a heptagon. Heptagon means 7-sided figure. This is 7 sides figure or 7-sided figure, 7 sides figure or polygon. A polygon which is having 7, a heptagon. We are given here heptagon. To find in this heptagon number of diagonals in the heptagon, that we have to find out solution. Now you know what is the diagonal means. Now if other than 2 adjacent vertices of a heptagon are joined, then we obtain a diagonal. So diagonal is obtained by joining other than 2 adjacent vertices. For example, if there is a polygon like this, these are the points here, vertices. So other than these two, if I join this, one diagonal, second diagonal, third diagonal, like this, okay, and other diagonals will be. So on these 2 sides are not joined. These two vertices are not joined. So other than 2 adjacent vertices, if are joined, we obtain a diagonal. So diagonal is obtained by joining any 2 vertices other than 2 adjacent one. So this is the diagonal here. What is the value of diagonals? We know that number of diagonals is given by n into n minus 3 upon 2. So number of diagonals, since number of diagonals in a polygon of n sides is given by the formula n minus 3 upon n upon 2, sorry, this is upon 2, n into, I think n into n minus 3, this is n into n minus 3. This is the formula for finding the number of diagonals. Okay, so in this case it is heptagon. This is the formula here, n into n minus 3, where n is the number of sides. Okay, for n sides figure, this is n into n minus 3 upon 2. Number of diagonals is this. Okay, so in this case, number of diagonals, if it is there, so we have to just put that how many diagonals will be here. Here n is equal to 7. Here n is equal to 7. Therefore, number of diagonals in a heptagon is equal to 7 into 7 minus 3 upon 2. So is 7 into 7 minus 3 means 4 upon 2. 2 to the 4 means 14. Number of diagonals in a heptagon is 14 is 14. So this is the answer here. So diagonals equal to number of diagonals. In this case, the formula must be known. Number of diagonals is equal to 14. This is the answer here. Okay. So here n is 7 because heptagon is 7 here. So n is equal to 7 here. We put the formula. And for example, if I take quadrilateral, now we know that in quadrilateral there are only 2 diagonals, 1 and 2. So if I put n here 4, so 4 into 4 minus 3, this is 4 into 4 minus 3 means 1 upon 2, 2 to the 4, only 2. This is exact one. So this is number of diagonals in quadrilateral is 2. This is 2 here. 4 upon 2 means 2. So 2 number of diagonals in a quadrilateral. If n is 5, then also we can find out 5 into 2 upon 2. So only there will be 5 there. N into n minus 3 upon 2. So 5 into 5 minus 2 means 3. Sorry, this is 5 minus 3 means 2. I'm sorry, upon 2. This 2 to cancel out. Only 5. So in case of pentagon, there are 5 diagonals. Good. Number of sides equal to number of diagonals in case of a pentagon. If it is 5 here, 5 into 5 minus 3 means 2. 2 upon 2 cancelled out, so only 5. In case of pentagon, so in a pentagon, number of diagonals is equal to 5. This is how we calculate number of diagonals. Okay. Let me take now next question. Question number 4. So in case of a heptagon, number of diagonals was 14. Now question number 4. Question number 4 now. Question number 4 says, what is the measure of each interior angle of a regular polygon of 12 sides? Okay. So to find, or what is given to us, we are given a polygon. We are given here a polygon of 12 sides. To find each angle of 12 gone or 12 sided figure, 12 gone, or a polygon of 12 sides, a polygon of 12 sides. We have to find out this is not 12 gone or, okay, 12 sided figure. Let me find solution here. Since each angle of a n gone means polygon of n sides, n gone means polygon of n sides, is given by 180 degree into n minus 2 upon n. This is each angle. So if here n is 12, here n is equal to 12, therefore each angle of a 12 polygon or 12 gone is equal to 180 degree into 12 minus 2 upon 12. It is 180 degree into 10 divided by 12. This is 2 6 2 5 6 3 18. This is 30 degree into 5, 150 degree each. This is 150 degree each. Each angle of this is 150 degree answer. Because 5 3 15. It was 5.6. 10 upon 12 means 5.6. 6 3 18. So 30 degree. Sorry, this is 30 degree into 5, 150 degree. Hence the answer is 150 degree. Each angle of a polygon of 12 sides, okay, is 150 degree. Is the answer here. So question number 4 we have completed. Now let me talk about question number 5. Question number 5. Okay. Now these are questions based on polygons. Question number 5. Now fifth question says, what is the area of a regular hexagon if its side is 6 centimeter? Okay, so to find or to given here, what is given to us? A regular hexagon. Given a regular hexagon, we are given a 6-sided figure. To find, this 6-sided figure is given. To find area, okay, to find its area. What is the area? Okay, area of the regular hexagon. First of all, let me write the formula for finding the area of a polygon, of a regular polygon. Since area of a regular polygon is given by 1 upon 2 into number of sides. How many sides are there? It is 1.2 number of sides into radius of the inscribed circle. This is into number of sides, whatever number of sides is there, into radius of the inscribed circle. Into radius of the inscribed circle. For example, in case of a hexagon, this is a hexagon here. Okay, so inscribed circle will be touching these sides at the midpoint. It will touch the sides at the midpoint. This is inscribed circle. Inscribed circle of a regular hexagon. Okay, so this is suppose center here. If I join this, so radius of this inscribed circle will be this perpendicular. This is radius of the inscribed circle in this case. Now each angle in case of a hexagon is 120 degree, because 180 degree into n minus 2 means 4, 6 minus 2, 4, 4 upon 6, 6 3 ja. 30 into this 120 degree each, so this is 60 degree. This is also 60 degree completely. This is also 60 degree. This is a, so this triangle in this case is equilateral triangle. Now we know that what is area of equilateral, but if I have to find out the radius, in that case also this is 30 degree. Okay, so if I find out this radius, and suppose this side is A, this is A side, all sides are equal, this is equilateral triangle. So in this hypotenuse will be, if I take this 30 degree here, but 30 degree, 30 degree, in terms of 30 degree, if I find, and in sides, the side, number of sides here, we have taken radius of the inscribed circle. So in terms of side, if I calculate, okay, with this 60 degree angle, in this case 60 degree, if I take, no problem. So this side will be the length of this height O, let me take A, B, and this is C. So OC we have to find out. So OC upon, if I take OC upon OA, in this case side is given. So OC upon OA, this will be, because this is perpendicular 30 degree I am taking, or 60 degree if I take, then perpendicular upon this. But if I take 30 degree, this angle, because this is angle bisector. So if I take this angle 30 degree, it will be perpendicular, this is base. So base upon hypotenuse is cos theta. So it will be cos 30 degree. Cos 30 degree is root 3 by 2. And therefore OC radius of the inscribed circle is equal to OA into this. This is root 3 by 2 into A. So root 3 by 2 into A is this radius of the inscribed circle. Number of sides is 6. So here area will be 1.2 into number of sides 6 into this radius, inscribed circle's radius is root 3 by 2 into A. Is it area 1 upon number of sides into radius of the inscribed circle? Area of a regular polygon is 1.2 into, and if I take this value, now this radius is this value A under root 3, so this is root 3 by 2, but this is side square, I think, A square. The number of sides is 6, so 2 3 is 6, 3 under root 3 upon A, but it is side square, I think. It is 2 3 is 6, not the proper formula, I think. Root 3, so but you know that what is value of the hexagon here, area of regular polygon is 1.2 into number of sides into radius of the inscribed circle. It is into side also, because if I take area, then it is side square, it will be A square here. It is 3 root 3 upon 2. This is side square here. We cannot say that this is radius of the inscribed circle, undoubtedly. Radius of the inscribed circle is there. But this will be 1.2, means this is 3 root 3 now upon 2 into side square or A square. This is side square here, it must be. Radius of the inscribed circle, undoubtedly, but number of sides into side also. Number of sides into that side. It must be radius of the inscribed circle is okay. So radius is in unit only, but it is area. It must be into side also. Number of A into number of sides into that side. Or if I take number of sides 6A, if I put 6A, or this perimeter here 6A, we have to put here 6A, not number of sides but perimeter of the that. This is not number of sides but perimeter in case of regular polygon. This is perimeter here, so it is 6 into A, perimeter into radius of the inscribed circle. This is okay. Now the formula is this, so this is 6A, perimeter in this case is 6 into A. So 6A, A into A, because radius will also take A, this is A square here. So 3 root 3 by 2 into A square. This is formula for the area of a hexagon. This area, if I apply, then the answer will be 3 root 3 upon 2 into side square. Okay, so this is the formula here. 3 root 3 upon, okay, so this is not number of sides, we can say perimeter of the sides, perimeter of the polygon, perimeter into radius of the inside circle. That is the proper formula here. Okay, so let me put here the formula for regular hexagon and then area. Area of a hexagon is, in this case, so area of a hexagon, regular hexagon in this case, equal to 3 root 3 upon 2 into side square into side square. This is the formula here. Let us take this question. So side is area of a regular hexagon. Okay, no side is given. What is the area of 6 sides? Side is given, I'm sorry. Of a regular hexagon of side is equal to 6 centimeter. Here side is 6 centimeter. It is 3 root 3. 3 root 3 into side means 6 square. This is square centimeter. Area will be done square centimeter. 3 root 3 upon 2 into 6 into 6, 36. 2 3 ja 2 3 3 9, 9 6 54, 54 root 3. 54 9 6 54 into root 3. If I multiply this by value of root 3, 1.73. 2 is also there, but let me multiply this. This is 54 here, 0 put. So 4 3 are 12. Okay, I am just multiplying by this one. So this is this value. Let me multiply 4 3 are 12, 2 1 carry, 4 7 are 28, 5 3 are 15, 28 and 15, 41, 41 1 42, 4 carry, and 4 1 are 4, 3 0 0, 5 7 135 and 4 39, 39 and 4 43. So 43, 4 carry again, 4 carry. Then 5 1 are 5, 7 0 0. 5 1 are 5 and 4 9, only 9. Then 0 into 1 is 0, nothing else. Okay, so this is the value here. Decimal after 2, it is 93. So answer is 93.22 square centimeter. This is the answer here. The formula you should remember for